Optimizing how your organization uses its vehicle fleet is important for logistic and service providers. In this video, we will discuss about challenges and demonstrate how to build and run a solution for many-to-many vehicle routing using Amazon Location Services. My name is Adil Ken. I'm working as a senior solution architect. I will talk about these challenges and Amazon Location Service details, and my colleague Ramesh Chidrala will present the architecture and follow up with a demo. The fleet management market size has grown rapidly in recent years. It will grow from 20 billion in 2024 and expected 24 billion in 2025 with an increase of 15%. Optimizing how your organization uses its vehicle fleet is important for logistics and service providers. So, what are the main challenges? High operational cost. Managing a fleet involves significant expenses, fuel, maintenance, insurance, and administrative costs. Without effective management, these costs can escalate, reducing our profitability. Optimal route planning leads to increased fuel consumption and longer delivery days. This inefficiency not only raises costs but also impacts customer satisfaction. Without real-time visibility, it's challenging to monitor vehicle locations and status. This lack of oversight can result in delays, mismanagement, and reduced responsiveness to unforeseen events. Handling, such as scheduled, bulk, and on demand, requires flexibility. Coordinating different vehicles types from trucks to bikes adds complexity to these operations. Our objective today is to introduce a comprehensive cloud based solution designed to address these challenges. The goal is to optimize order management, reduce operational costs, and enhance overall fleet efficiency. By implementing this solution, we can transform our fleet operations, making them more efficient, more cost effective, and responsive to our needs. So let's start and deep dive on Amazon Location Services. What's Amazon Location Service? Similar to everyday maps applications that we are using, but offered through the AWS platform. Amazon Location Services is tailored to B2B use cases powered by data from Grab Maps. The capabilities are customized, can visualize data on map, recommend delivery routes based on real-time traffic conditions, convert plain text addresses into geographical coordinates, convert customer and vehicle positions into addresses, and monitor the track. The slide highlights practical use cases for the capabilities of Amazon Location Services. The first one is visualize location information on a map. The map capability to display geographical data in your application. Such examples are show store locations, delivery routes, or real-time asset tracking on a map. Second, it offers point of interest search functionality. Leverage the places feature for geocoding and search. Third, it retrieves current and historical location of devices. Fourth, you will get travel time, distance, and directions. Use the route feature to calculate optimal paths between locations, including estimated travel time and distance. And finally, the detect and act when a tracked device enters or exits a boundary. Employ the geofences feature to set up alerts or trigger actions when devices cross predefined boundaries. So, how to start using Amazon Location Services? The first step is select the data provider and capabilities. By choosing the data provider and specific location-based features you need, such as maps, geocoding, routing, and geofences, you will add the AWS SDK into your application. The SDK simplifies integrating by providing pre-built tools to interact with Amazon Location Services. If you are using another location-based service, replace those API calls in your code with equivalent calls to Amazon Location Service APIs. By switching to Amazon Location Services, you can benefit from improved data accuracy, reduced cost, and enhanced user experience in your applications.
Let's go through the solution architecture. The web interface, built with AWS Amplify, gives dispatchers a clear view of their delivery operations. Through Amazon Location Service, they can create optimized routes and track vehicles on interactive maps. AWS AppSync ensures all information updates in real time, while AWS IoT Core processes the continuous stream of location data from vehicles. behind the scenes, Amazon DynamoDB stores all delivery and route information, with AWS Lambda handling the route calculations. The architecture can be divided into three components: route entry, route calculation, and route tracking. Route entry component leverages Amplify low-code React development with AWS AppSync and Amazon DynamoDB to enable a field service dispatcher to enter and store destination and waypoint locations from a map. The route calculation component leverages AWS Lambda, location services matrix routing, and AppSync to automatically create an optimized lowest cost route based on the shortest time to complete the trip and then displays the optimized route on the map. The route tracking component integrates the application with AWS AppSync, AWS IoT Core, and Location Services Tracker to track our driver on the map as they complete their route. Let's see how this works in practice using a real-world example. We will walk through a scenario for a delivery company operating in Chicago's metropolitan area. The dispatcher is planning the deliveries for the day, starting from their distribution center to various locations. Once you deploy this solution and run it in your browser, you will be presented with the login screen. You can create an account using your email address and use it to sign in. After signing in, you will see the web-based dispatcher interface. We will now create an itinerary for today's schedule by entering a name and choosing a date. The Create Itinerary screen displays an interactive map and enables route entry. The dispatcher can specify route starting with the first location. As the dispatcher enters the address, Amplify's location search feature is used to display matching addresses out of which the correct destination address can be chosen. After entering all the addresses, the dispatcher is now ready to optimize the routes. The itineraries are optimized using Amazon Location Route Matrix API. This API returns a matrix with the distance between each pairs of points of the itinerary. The matrix is then used to optimize the route based on the shortest distance between each pair of waypoints. After optimizing the routes, the dispatcher is now ready to start the itinerary. Once an itinerary starts, an asset outfitted with an IoT sensor sends position updates to AWS IoT Core using the message queuing telemetry transport protocol. For the purposes of this demo, the route tracking component simulates an IoT sensor installed in the vehicle. AWS IoT Core routes the messages to a location service tracker, which stores the position updates for up to 30 days. Users of the application can track the assets on the map in near real time. This is achieved by pulling the updates from the Amazon location tracker through an AWS Lambda custom AWS AppSync resolver. This concludes our demo. We have seen how Amazon Location Services helps organizations optimize their fleet and delivery operations with route entry, route optimization, and real-time tracking. The QR codes you see here point to the solution guidance and sample code on GitHub, which can be used as a starting point. Thanks for your time and have a great day.